Next up, we're going to be finding the phase shift of f of x equals 3 times sine of pi x minus pi. Now again, I've said this before, I'll say it again. You can easily figure out the b and c value, and just we know that the phase shift is negative b over c, or negative c over b, sorry. But there's an even easier way to do that, or at least an easier way to remember. All you have to do is set what's inside of the parentheses equal to 0, because we know that will give you the initial value of the wave or the shape of the wave for sine or cosine. So I'm just going to set pi x minus pi equal to 0. I probably need to shift this over a little bit so I can have some room. Okay, the next thing I'm going to do is add pi to both sides. So I get pi x equals pi. I'm going to divide by pi, divide by pi. Pi's will cancel on the left, and final answer, I get x is equal to 1. That's what pi over pi equals. So therefore, my phase shift, and again, I just like to write p dot s, is going to be equal to 1. And we'll put plus 1, meaning that it's going to be moving 1 to the right from its initial position. So let's go ahead and take a look at the graph and verify that our function here, 3 sine of pi x minus pi, has shifted 1 unit to the right of its initial value at 0. I'll have to be honest, this one almost threw me off, but the initial sine wave is this gray wave, so we see that the middle of the wave is at 0, obviously. Our new function, 3 sine of pi x minus pi, we see that the new middle of the wave is indeed at 1, even though it's a lot skinnier, and that's kind of what threw me off. But anyways, that verifies that our phase shift is equal to 1. That's it for this example, folks. If you have any other questions about it, let me know.